All right. I'm only going to do this from the left side, but if you want to see how you could go backwards and do it from the other side, actually, I'm going to do it from the right side. But if you want to see from both sides, screw it, I'll just do it. All right. So let's say I started from the left side this time because it's more, or the right side because it's more complicated. So I would go ahead and write, all right, I'm starting from cosine of x, 1 minus sine squared of x. Again, I chose that side because it's more complicated. I know I'm going to want everything in terms of cosine. Hey, you should already have something going off in your head. We have a squared here. So we have to think, is this one of our trig identities? Our main ones are sine squared x plus cosine squared x equals 1. Well, I want 1 minus sine squared. Well, here's 1. If I minus sine squared over, hey, that's going to be equal to cosine squared. So then I can replace this with cosine squared of x. And then this is still cosine of x. Well, cosine of x times cosine squared of x is cosine cubed of x. Proof and done. That one was fast. If you want to go the other way, start with cosine cubed of x. We know nothing about cosine cubed. It's not one of our trig identities, but cosine squared is. Well, I know I could split this up as cosine squared times cosine of x. Oh, I want this in terms of sine. Now I can write it in terms of sine. Again, if I wanted cosine squared by itself, I'd subtract that over. I'd get 1 minus sine squared, so I'm just replacing it with my Pythagorean identity, cosine of x. The order we multiply in doesn't matter, so I can just rewrite it. And I'm left exactly where I wanted to be. Proof done. So that one wasn't too bad. So that's number 7. Number 8 is the same premises, so I'll do both again for you guys. I have sine to the 5th. If I want to start with this side, I don't know what sine to the 5th is, but I know what sine squared is, and one of those fits in there. Actually, 2 of those fits in there, because sine squared times sine squared is sine to the 4th. And then I have one left extra. Now, the reason that helps me out is because I want things in terms of cosine. Well, I know sine squared is equal to 1 minus cosine squared. Sine squared again is 1 minus cosine squared. And then I have sine of x. Then I'm just going to FOIL. It's the only thing I can do. 1 times 1 is 1. Negative cosine squared x. Negative cosine squared x. Negative times negative makes positive. Cosine squared times cosine squared is cosine to the 4th. And then I get sine of x. Combine like terms. 1, I have 2 of these. So minus 2 cosine squared x plus cosine to the 4th x. And I still have my sine of x. Hey, that's exactly what I wanted. Proof is done. Could you have started from the other side? Yes. Generally, that's where I start. This is a quadratic in disguise. So if I'm starting with that side, oops, it's cosine, not sine. In proofs, you can do something we call u substitution. That's where I say, hey, u is going to be equal to cosine squared. So this would look like 1 minus 2u plus u to the 2nd. It's a quadratic in disguise. So we can factor it. So I'm looking for something. So I'm going to set up my parentheses to factor. Instead of u, though, it's going to be cosine squared because that's what I made u. I need something that multiplies up to positive 1, but adds up to negative 2. It's negative 1 and negative 1. And then I still had this sine of x on the outside. So I just factored that because it's a quadratic in disguise. And if you really wanted, you could have rewrote it in standard form. That helps kids too. Then this is a trig identity that says, hey, this is sine squared. This is sine squared. This is sine. Well, sine squared times sine squared is sine to the 4th. And then I still have times sine to the x, which is sine to the 5th. Proof and done. So again, you can either split it up, or you can say, hey, this is a quadratic in disguise. So choose your side wisely, then you can prove it either way. And that's how you do 7 and 8.